Birthday to you.
Happy birthday, dear Alex. Happy birthday to you.
Okay, that's officially in the class record. Awesome. Frequently in your life.
1/2 base times height.
Area equals 1/2 base times height. Why? Why does that work? Yeah.
Because if you take two triangles and like if you take two congruent triangles and flip one over, so it becomes like a parallelogram. It's just saying like base times height is the area of the triangle.
How do you know base times height is the area of a parallelogram?
I actually can't answer that. So if you have a parallelogram and you like cut off one side and add it on the other side, it's right.
Okay, so what do you say? So proving this relies on knowing that this is 1/2 of a parallelogram. Come on. This is not being cooperative. Hold on a sec. Okay, so 1/2 of a parallelogram. So therefore, in order to prove that area function for a triangle, we need to prove that the area of a parallelogram is 1/2 base times height. So we need to prove this. Prove that the area of a parallelogram equals base times height. Try to draw me a picture that proves that. Do that right now. Draw me a picture. We want to call it a parallel. It's a parallelogram. So what can we add in if that's a parallelogram? What do we have to add in to label that as a parallelogram? What? Yeah, we need to show that this side parallel there and those are parallel there. And then what else should we label? We could now label congruent angles, absolutely. So we know that that's congruent there. That angle is congruent to that angle. What else could we label? We've done angles and parallel, but what else? What else is congruent here? Lengths, yeah. So that side length is congruent to that. This side length is congruent to that side length, exactly. So what did you do? You cut off, we'll call this triangle A, B, C. Which distance in this case is the height? A to C is what we're considering to be our height. Agreed? Now what did you do with that triangle ABC? Yeah, you cut it off and you moved it to the other side. So this would represent A prime, this would be B prime, and this would be C prime. Now how do you know that this is true, that these triangles are congruent? Yeah, you end up with angle, angle, angle. That's true. But what else? You also end up with side, side, side. You actually end up with side, side, side because you know that A to C is going to be congruent to A to C prime, and you know that A to B is A prime, B prime, and you know that B to C is B prime, C prime. Does that make sense, everybody? So you know that they're congruent. So you know that if I chop that off and put it over there, we know that the area of parallelogram. How did we label this? C prime, B prime, B, C. That's the original parallelogram. What's that going to be equal to? Equal to rectangle what? Yeah, A prime A, C, C prime, right? But that's a rectangle, and we know that the area of a rectangle is base times height. So at a certain point, you just have to come back to something that you take on faith, and we can take on faith that the area of a rectangle is base times height. So we use that to prove that the area of a parallelogram is also base times height. And any triangle equals 1/2 of a parallelogram. So how do you form that parallelogram from any triangle? For example, if I gave you, I don't know, let's give you, how about this one? If I gave you this triangle right here, how do you turn that into a parallelogram? If I did A, B, C, what do I do to triangle ABC? How do I turn that into a parallelogram?
You have to reflect angle B.
Yeah, so you take this shape and do what with the whole shape? You reflect it over what?
No, you have to rotate it 180 degrees.
Ah, it's at this. You might have just said the same thing. Ready? So we're going to take this, paste it, try to highlight it and have it not out. Oh, we can have it freak out. we're going to take this and see if I can find it here. Rotate what we want to rotate right on 90 degrees, and we're going to rotate right 90 degrees again. What do we do with that?
You attach C to A.
180 degrees.
There it is, right?
Yep.
So what did we just create?
Parallelogram.
And we know that that's a parallelogram because we know that this angle is congruent to that angle. We know that that angle is congruent to this angle, and we know that this angle is congruent. B is congruent to B. So because we have opposite pairs of congruent angles, we know that that has to be a parallelogram. So we just proved that the area of a triangle is 1/2 base times height because we know the area of a rectangle is base times height. Yes, Dixon.
Do you have to put more in those marks because
Exactly. So I'm going to give you a side length and say, the triangle. So how about triangle with S equal to 2? Find me the area of that triangle. Area equals. Do that right now. What's the area equal? So draw a triangle with a side length of 2. Here's the diagram we're working with. So we need to find H. What's the base?
2?
The base is 2. The base of this triangle is 2. Correct. But we need what? Height. We need the height. How do we figure that out? How many triangles did I divide that into? 2 of them. What's the base of each of those triangles?
Wow.
It is 1. You can say it bisects it. So you know that h squared plus 1 is equal to 2 squared. So h squared is equal to 3. So what's the height equal to? Root 3. So the area of this triangle is 1/2. What's the base? Times, which is square root of 3. Okay, so we just did a regular, so we just did an equilateral triangle. So let's do an easier one.
I have a question.
Yes.
Where you had H squared, 1 squared.
No. That was in terms of the side length of 2. That's in terms of the side length of 2. So let's say I generalized this and went back to triangle and said it was S, S, and S. What's the area of the triangle? If I did it in terms of S, S, and S, what's the area of the triangle? So you just did it in terms of 2. Now you need to do it in terms of S. So let's do this out together. So if we have S, S, and S, we're going to do the same exact work we did before. If this is S and S, what's the base of those two triangles? Over 2 and S over. So we need to find the height again. What's the relationship we now write? Instead of 1 squared plus h squared equals 2 squared, what are we going to write instead? S over 2 squared plus equals. So we have h squared is equal to s squared minus what? S squared over what? Nope. 4. If you have 1 of something and you subtract a quarter of it, what are you left with? So 3/4 s squared. We take what of both sides now? We take the square root of both sides, and I don't know what just happened there. There we go. Take the square root, and what do you end up with? H equals root 3 over 2 times s. That's the height in terms of what? We had a 2 by 2, 2, 2, 2 triangle, right? Plug 2 into that. What do you get? Plug 2 right here. What do you get? Square root of 3. Was that the height we got before?
Yep.
Now we can do this for any s value. So what's the area of this triangle? 1/2. What's the base of this triangle? The total base. S. And what's the height? S. Can we simplify that a little bit? So area is what? Root 3 over what?
4.
Times s what? Squared. So you just found the area of a triangle, equilateral triangle, entirely in terms of what? Entirely in terms of s. You found the area of a square entirely in terms of s is what? S squared. Absolutely, it's s squared. So what would be another thing I could ask you? If you just found the area of a triangle in terms of s, equilateral triangle in terms of s, and then you found the area of a square in terms of s, what could I theoretically ask you for next?
Pentagon.
Area of a regular pentagon, hexagon, etc. in terms of Let's try looking at a pentagon. How many sides in a pentagon? We have 1, 2, 3, 4, 5, and they're all going to be S, 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 and S. Correct. So we're trying to find the area of that shape. Any ideas about how we could go about doing that? Yeah.
Well, since you know that it takes at least 3 triangles to form, you make 3 triangles because.
You can make 3 triangles. Okay, we can do that. Sure. So we do this. You're saying do it there?
Yep. And
Then what though?
you see the right farmost triangle.
This one? Mm-hmm.
You can find the area of that
How?
because you have 2 side lengths.
So? It's not an equilateral triangle.
Oh.
Like, you don't know. That's a very good guess, but do you know what the length of the thing is? Nah. You know it's the same length of this one. I agree. If it was the same, but this formula, the s squared times root 3 only works if it's side, the same 3 sides, right?
Okay.
Is that the same length? No, it's not. It's what? 5 what? How so? A star thing? Okay, I think I understand what you're saying. You're saying do this, and I'm going to draw a better pentagon. Is that that's a pretty bad pentagon, isn't it? That's still a bad pentagon. Is there a pentagon shape up there?
My computer.
I don't have a pentagon. That's too bad. Okay. So you're saying I think do this. Okay, if you do that, each of these is S, right? Do you agree? How many degrees are in a circle? 360.
Divide by 5.
We divide 360 by 5. What do you get? 72. So each of the 2 degrees. So is this an equilateral? Are these equilateral triangles?
No.
No. What would it need to be if it was an equilateral triangle? 60. It would really need to be 60. So are we? Does this help? Not really. But I like this idea. Drawing more triangles. I like this idea. How does it help us?
Because you know that the other 2 angles are the same.
Okay, so you know that that angle is the same as this. Okay, so yeah, because so you know that's R, that's R, that's R, that's R, and that's R.
And then basic 180 minus 72.
Okay, so you know the angle lengths, but how is that going to help you? That's what I totally agree that the angles would be very helpful, but you guys don't know trig, so angles other than really nice ones like 60 are going to help you too much. What? We're finding area. That's correct. Does anybody see any other triangles we could draw? Yeah, Missy. And bisect the side length. So you want to do this, I see. So you want to do this like that? Like this? Sure.
And you have right triangle.
Okay, you now have right triangles. I agree with you. So I agree, Missy. If you found this height, would you be done? If you found that height in terms of S, would you be done? Yeah, because if you have height and base, what can you find? And then you multiply it by 5. So if you found H in terms of S, you would be done. The question is, how do you find H in terms of S? Any ideas?
If you put square triangles on the other side,
Ah, I like this idea. Lynch has this idea, and I like this one. This is the one I think we're going to go with. Mainly because do I like 72 degrees? Not so much. So instead, she wants to do this. Well, first, draw a pentagon. They're hard to draw. It's better, I guess. So each of these is S. So what did you want to do? This? Okay, that's cool. I like that. Okay. And I'll label some points here so we can talk about it. So we have A. I'll make that red. A, B, C, D, E, F, and G, and H. There's 4 triangles. Are all 4 triangles congruent? You sure?
No. Yeah, because it's a regular.
Why? How do you know they're congruent? I mean, I see that. I see that these 2 triangles have to be congruent, and I definitely agree that these 2 triangles have to be congruent. But how do you know that, for example, you know that this and this triangle are congruent?
Oh, because they're...
Well, I agree that those are 90 degrees. I agree that that's 90 degrees, correct? And I do agree that this, hold on, this side is congruent to that side, and this side is congruent to that side, correct? I agree with that.
They share two side lengths and an angle.
They share two side lengths and an angle?
They
Share a side length and an angle.
Well, no, because all of them have like hypotenuse and S.
That's true, but the other two sides, do you know how HB relates to FC?
I have a question.
Yes, go ahead.
Is G in the center?
So we stopped this one and said, okay, Pentagon, we don't really know how to deal with 36 degrees and 54 degrees and 18 degrees. We don't really know how to deal with that, do we? Let's look at a hexagon and see if it changes at all. If each one of these is S, what triangles do you want to draw in this time? Yeah? You want to do the vertex to the center again? Okay, if we do that, you mean this right here, Missy? What's the angle of each of these? Ah, it's 60. Correct. What's the whole angle right here? Well, what's the sum of the internal angles? 180 times what? 4, which is going to be 720. And how many angles are there inside there? How many internal angles? 6 of them. What's that equal? What's 720 divided by 6? What? 120. Each of these angles, like this angle right here, see that angle? Is that going to be then half that? So each of those angles is what? 60. And if 2 angles are 60, what's the third one have to be? 60. So each of these triangles is what? Equilateral. They are similar, that's correct, but be more specific. They are equilateral, and each of the triangles is equilateral, and all 6 of them are congruent. So you have 6 triangles that are S by S by S. You have S, 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 S. All those are S, right? Do we know what the area of like an SSS equilateral triangle is?
Yeah.
Yeah. How many are there?
6.
So the area of this is going to be 6 times root 3 over
2.
4 times
Why
S
4?
squared. Because the area of the triangle was root 3 over 4 S squared, right? But how many of those triangles do we have?
6.
So this area is going to be 3 root 3 over 2 times S squared. So was that really nice? Because what's the whole key to that? What angle do we need? We absolutely had to have 60 degrees. Did it work if we didn't have 60? No, it did not.
Wait,
So this one, yeah, go ahead.
why not though?
Why not what?
Your final area equation, you just did 6 and then times the equation for...
If you have a triangle where the sides are not all equal. That's your homework this weekend, and also about. And if someone could bring this in, I don't know what it is, so if someone could bring this in, think about
Pentagon?
the area. No, ready? This is the one. Kids, I'm still talking. Area of a regular n-gon. So what the formula is entirely in terms of the number of sides and S.
Square.